Welcome to the last session of our 5-week journey. Let me start the video too. So, I couldn't finish what I was really planning to do, but I think we spent time on mostly on pre-processing, and I can tell you most of the time you're going to be spending on any machine learning project will be actually on pre-processing of data. So we haven't even covered pre-processing itself. It takes a lot of time, a lot of effort actually, 70–80%, depending on the project type of the data you are working on. It requires cleaning, sometimes aggregating, imputation, right? Merging. So a lot of things that you have to do, transforming the data sets to make it ready for any algorithm to run with. Actually, once you have a clean data set, you can simply try different machine learning algorithms, tune them up, and then considering some metrics, decide on which one will be working the best for you. Up to that point, you have to carefully actually work on the data set. So today I'm going to, remember from last time, we talked about pipelines, lastly, if you remember. Today I'm going to continue with pre-processing, and mostly today's lecture will be hands-on. So we are going to spend some time on categorical variables and column transfer, mostly scikit-learn library, and then do some interesting stuff on, again, simple data sets, and then just think how it can be complicated when you work on really dirty data sets. Okay, so let's begin with categorical variables. That is another thing that we have to really pay attention to when we are pre-processing data sets. The data set may have numerical attributes as well as categorical attributes. Categorical attributes are going to take discrete values. Sometimes these discrete values are going to look like text, like strings, and sometimes they're going to be numbers, and sometimes they're going to be Boolean values. So Boolean means true, false. They can be numbers, but numbers do not make them numerical variables. For example, you can simply assign 1 to freshman, 2 to 3 to junior, 4 to senior. So you can simply assign integer values to categories, but this doesn't make that categorical variable a numerical variable, right? So let's just begin with how we can deal with categorical variables. Again, in order to run any machine learning algorithm, we need to turn categorical variables into numbers. So let me see. I have some questions. Yeah, so we are still using the third module. Okay, so let me give the link in case you don't have the link to the material. We are still using the third module. All right. So on the screen you see this data frame, which is composed of borrow and salary and vegan. As you see, there are 2 columns which are categorical. Borrow is name of a place. Vegan is an attribute, right, of a person. So these rows are corresponding to individuals. I don't know why I cannot see the questions. Just let me see. Yeah, this is going to be the last day of this series, and I'm sorry, I really don't know about the test, when it is going to be held. So probably you're going to receive an email from Magnimind. Okay. And then we have salary, which is numerical, right? So we have 3 attributes. 2 of them are categorical, 1 of them is numerical. Again, this by itself, as of now, will not work for most of the machine learning algorithms. Then we need to take care of this categorical variables. First of all, vegan is going to be our target variable, and borrow and salary are our feature sets. So what you can do is we can assign ordinal values to borrow. Ordinal means those string values are going to be assigned with numbers, and these numbers, the order in which these numbers are given has some meaning, right? So for example, 1 is greater than 0, 2 is greater than 1, and actually the distance between 2 and 1 is 1, 1 and 0 is 1, and 3 is also greater than 2. So when you have nominal values assigned to your categorical variable, those values, the distance between those values and the order in which those values are placed will have some meaning, right? So if you come up with some model which is going to classify vegan and non-vegan, right? No and yes. And then if you simply assign these nominal values to your borrow attribute and then run some very simple linear classifier, this linear classifier is going to come up with this these two regions. Like on the left region, and anyone with borrow value less than 1.5 are actually going to be vegan, and greater than 1.5 will be on the non-vegan region, which doesn't mean anything, right? The reason why we have this vegan region is because borrow values equaling 1, we have 2 data points with vegan equals yes. Right? If it is less than or equal to 1.5, so we have more number of yeses. And if it is greater than 1.5, we have more number of no's. So that's why this linear classifier came up with these 2 regions. So clearly this is not, this is misleading. This is not a good way to approach this categorical variable. Instead, what we're gonna do is we are going to assign dummy variables to these categorical variables. So pandas, this library pandas has a very simple actually function called get dummies here. So if you put your data frame, this is df is the data frame. If you put your data frame and call this data frame with this function get dummies df, what's going to happen is anything that is not numerical, as you see, there are 2 non-numerical categorical variables. Anything which is not numerical will be assigned with dummy variables. Dummy variables are simply codes. Like Bronx is represented by this column. So anyone who lives in Bronx, like this 6th person, 219 salary person, he's living in Bronx, right? So then the value for this column is 1. And actually this person has all the 0 values for any other borrow. So that's how you actually differentiate between anyone who's from Bronx from Brooklyn or from Manhattan. So the same goes for with vegan and non-vegan. Okay, so this is one way of creating dummy variables. Get dummies is going to create dummy variables for any attribute that is not numerical. What we can do is, instead of making all non-numerical or categorical variables, instead of turning them all into dummy variables, we can assign, okay, we can specifically let get dummies turn some of these categorical variables into dummy variables like this. So columns is a list of names of the columns which are going to be turned into dummy variables. In this case, we have 2 columns, and then we want only one of them turned into dummy variables, in this case, borrow. As you see, vegan is kept as categorical, but Bronx and Brooklyn, Manhattan, Queens, these are the names or the categories of the borrow attribute, and they are turned into dummy variables. Yeah, so we can do the same thing with, remember this, data frame, which we assigned the ordinal values to borrow. So we can also even turn integers. Actually, these are not integers, these are categories, right? We can even turn them into dummy variables. Okay, here borrow doesn't look like a categorical variable, but it is a categorical variable, and then we can turn this into dummy variables. All right, so there is one problem that we have here. The problem is on the left-hand side, if you have, let's say, a training data set, okay, if you have a training data set and then you want to train your model, before you train your model for any algorithm, you need to turn your, let's say, borrow attribute into dummy variables. And you do that, right? So now we have dummy variables, values for Bronx, Brooklyn, Manhattan, and Queens, right? So these are the different names of the borrow. All right, then let's say you received a test data set or a new data point, right? And what happens if this new data point or this test data set has, again, borrow, it has the borrow, which is the categorical variable, but one value of borrow, one category, in this case, Staten Island, was not originally in our training data set. Okay, so in our training data set, we had Manhattan, Queens, Brooklyn, and Bronx, and we have the code for that. Now we have this new data set, and we again turn borrow into dummy variable, but this time we only have Brooklyn, Manhattan, Queens, and Staten Island. So we don't have Bronx anymore. Instead, we have Staten Island. And this new data set, the last column means a totally different thing than the last column here. All right. So, I mean, everything else like Brooklyn 0, Manhattan 0, Queens 0 means this person is Staten Island. In this case, I mean, Brooklyn 0, Manhattan 0, Queens 0 would mean this person was in Bronx, right? So now we have some confusion here. The confusion, the reason for the confusion is that we have new category in our categorical variable that was not originally in our training data set. Okay, so this may create some problems, and then now let's see how we can address this problem. What we can do is, again, with pandas, what we can do is we can specifically again tell that, you know what, I mean, borrow, okay, borrow, it's a categorical variable, okay, and the entire set of categories for this variable is, the entire set of category values for this variable is Manhattan, consists of Manhattan, Queens, Brooklyn, Bronx, and Staten Island. So we, in advance, tell our get dummies that, yeah, I want to create dummy variables for borrow, but borrow is supposed to be taking values from this list, Manhattan, Queens, Brooklyn. Even though I don't have all of them in my training data set, I know that I might receive some new data points with, let's say, Staten Island, even though it is not in my current training data set. So in that case, I'm not going to have this problem because, as you see in my transform data set, even though I don't have Staten Island in my training data set, I still have Staten Island showing, right, in my transformed data set. So this may address that problem of, you know, not having one category showing in the trained data set. So I see some questions, just 1 second. Yeah, if the new category is not known in advance, I mean, we have one solution for that with scikit-learn, which we're gonna learn shortly. Yes, when you create dummy variables, you are actually creating new attributes. So you are simply increasing the size of your data set. So that's why, again, in this lecture, we're gonna see when you have categories with a high cardinality, let's say zip code, right? So there are so many zip codes in the United States, right? So if you turn zip code, it's a number, but it's not an integer number that you can use. That number doesn't mean anything. It's a category, right? It represents a geographical location, right? Or maybe a group of households in a geographical location. So in that case, if you have so many different zip codes, we call this high cardinality, then using dummy variables may simply explode the size of your data set. So then you need to be a little bit creative and then come up with some other solution for that. Okay, again, we're gonna learn in a minute, all right, about this. Okay, so this is pandas. You can always use pandas, get dummies. It's very simple. A lot of people are using get dummies. You can also use one-hot encoder, which is available with scikit-learn. And one-hot encoder turns, I all your columns into dummy variables. And when it does here, as you see, when you say one-hot encoder and fit, again, one-hot encoder is a transformer and you are fitting. And then when you transform, don't see this to array. When you transform, your transformed data set is going to be a sparse data set, right? Because for each column, you're going to have a lot of zeros. Because it's a sparse data set, scikit-learn by default transforms these data sets as a sparse data set, means it only holds the non-zero elements. So if you want to see this as a matrix with all its zeros and ones, as one full matrix, then you need to turn this transformed data set into an array. Like you need to use this to array. So that's why we have this to array here. Because we have to array, we can see these zero elements as well. Okay, so we have this one-hot encoder. It doesn't look very attractive, right? So all the columns are now turned into dummy variables, which doesn't make too much sense. We want to control this, right? We want to control, like we did for pandas, which of the columns will be turned into dummy variables. So let's see what we can do to control it. Remember from our previous lecture, we had this pipeline and make pipeline. Right? Remember this? We were putting transformers and one estimator. Again, please remember, a pipeline, you can put multiple transformers and an estimator. You can switch estimators, but always you will have one estimator in the pipeline. But you can always switch the estimators. So similar to pipeline, which was holding multiple transformers and an estimator, what you can do is you can do different things on different columns. And then instead of doing this separately, as you could transform your data and then make another transformation, then another transformation, and then you could train an estimator. Instead of doing this yourself step by step, right? We put this into a pipeline. We can do the same thing using make column transformer for column transformers. Okay. So on the screen, which again, we're gonna do examples today, hands-on examples, so just be patient. On the screen, you see I'm using make column transformer. This is scikit-learn. So make column transformer is holding two tuples. This is the first tuple, right? And this is the second tuple. And those tuples are separated from each other with a comma, right? So each tuple, is, in this case, is holding two elements. The first one is the name of the transformer. You remember standard scalar from last time, right? Standard scalar takes in numeric attributes and then centers that attribute around 0, the origin, and then also controls the variation, right? So basically, we are creating a normally distributed variable with 0 mean and the standard deviation equals 1. And we have one-hot encoder. We just learned about one-hot encoder. What one-hot encoder does is it creates dummy variables for all the columns, right? For all the columns that one-hot encoder is applied to. So what we are doing here is actually, we are taking our data frame. This is our data frame. What is data frame? Think of data frame as a matrix with rows and columns, but it is not just that, okay? So that rows and columns, they also come with certain attributes and functionalities. Remember from our previous discussions, you can take a data frame and then like df is the name of the data frame, df.plot. So you can plot something, right? Plot two attributes with respect to each other. Right? So plot is a function. So df comes with that function. df has so many attributes and functions. It is not just a record of columns and rows. Okay, columns and rows are holding the values, but df data frame comes with those methods, those functions. Okay, one of those attributes is actually d types, is holding the type of the attribute. So df is coming with multiple columns, data frame. Each column has its own type. It can be an integer, or in this case, if it's an object, it's not numerical. Most likely it is categorical. So actually we are taking some shortcut here. So what we do is any column which has the data type object, okay, any column of our data frame which has the data type of object, I call them categorical. So categorical is holding Boolean values. Now Boolean is false, true, or true, false. Okay, so let's say you have 5 columns. The first column is numerical. It's not an object, it's integer. Then the first column will take the Boolean value of false, because we are checking the type of columns, whether they are object or if they're not object, then the Boolean value is false. Let's say the second column of df is categorical. In that case, df.dtypes for that column, the second column, which we assume it's categorical, when we check whether it's an object or not, the Boolean value returned from this will be true. So categorical is actually a list of Boolean values, false, true, true, false, like that. So if you like, you can take the not categorical. Not categorical is actually you're reversing true to false, false to true. In other words, if something is not categorical, it's numerical, right? So what I'm doing here is I am implementing standard scalar on all the columns which are not categorical, in other words, which are numerical, and I'm implementing one-hot encoder on all the columns which are categorical. So what happens with make column transformer is it takes your data is composed of columns. Here, I already separated my data into 2 groups, right? One group is some of the columns are numerical, some of the columns are categorical. Numerical ones are going to be transformed using standard scalar. Categorical ones are going to be transformed using one-hot encoder, means I'm going to create dummy variables. So make column transform is going to return this transformed data set. As you see here, I'm controlling which columns are, in this case, going through standard scalar transformation, and which columns are going through one-hot encoder. Okay. Nice thing is, I call this transformation. I haven't transformed anything yet. I just created this instance of transformation, and I name it as preprocess. Okay. So what I do now is I am putting this preprocess instance inside a pipeline. We know what pipeline is, right? So pipeline has now 2 members. First one is preprocess, which is a transformer. Second one is the estimator, logistic regression. So when I say model.fit in parentheses x train, comma, y train. So what's going to happen is I'm going to take my x train, I'm going to pick all the numerical columns of my x train, standard scalar, all the non-numerical categorical columns of my x train dataset, one-hot encoder, okay? And then I'm going to take this transformed dataset, scaled and dummy variable transformed dataset, and fit this dataset, fit logistic regression on this dataset. That's what this make pipeline will do when you fit model.fit, when you fit this make pipeline. Okay, I see some questions. Just give me a second, please. Yeah, I sent the link in the chat. Okay. Y0.1. Just it's just the way scikit-learn is storing the values. Okay, instead of 0, 1, it's going 0.11. Not a big deal. I'm going to explain the last line again in a second. How is an array present in database visually? Is it through separate tables or views? So now you are talking about a different thing. So it's, think of this as a table, okay, not a view, as a table. Okay, the last line is simply, there is no questions here. Yeah, with categorical object is categorically 1 times n matrix. It's not a matrix, it's like a vector which holds Boolean values, true, false values, and each Boolean value corresponds to a column. So you are basically checking if that column is numerical. If it is, in this case, let me close this, I cannot see the screen myself. So here I'm checking if columns are object or not. In other words, columns are categorical or not. If a column is not categorical, then this categorical value will take false value for that column. If that column is categorical or its D type is object, then this categorical will take true value for that column. The last line is simply a pipeline. The first member of this pipeline is this preprocess, which is transforming numerical ones into numerical columns into taking the standard scalar transformation of numerical columns and creating dummy variables for the non-numerical or categorical columns. And the second one is, after this thing is, after the data is transformed, next thing is we are implementing logistic regression, or we are fitting logistic regression on our data set. Okay. Again, just be patient. We are going to do some examples with this, okay? So this is how it looks like, column transfer. This is our continuous or numerical variables, continuous variables. This is categorical variables. You can do different things. And then all these different transformations, you can concatenate them. So what's happening here is, again, red is corresponding to continuous, blue is corresponding to categorical. You can do multiple things. For example, you take your numerical ones and then scale them as we did, right? Standard scalar. Again, you take the same numerical ones, the non-transformed numerical ones, implement principal component analysis. This is an unsupervised method. The main objective is dimensionality reduction, right? And then you can, if you like, you can also work on your categorical variable and take the one-hot encoder. As you see, the moment you implement one-hot encoder, the size of the data is increasing, right? Because we are adding some additional columns, right? And then you just concatenate them. That means, you just put them together. So as you see now, you have a larger data set, okay? And then some of the categories are, some of the columns are replicated, but with different transformations. For example, this PCA is, these columns are new, actually, these are new attributes, which are linear functions of our numerical columns, right? Okay, so one thing about, let me see, just 1 second, some questions. It is doing, the concatenation happens automatically. When you run make column transfer, when you fit, when you fit, it happens automatically. So if you like, you can do this manually yourself and then concatenate them. So if you like, you can take the standard scalar of your numerical values and then implement PCA on them, concatenate. That's what we were doing actually before this make column transfer was introduced, was cycled there. Yeah, the non-numerical D types are considered as object. Are there other encoders besides, of course. So the one that we saw at the beginning, are there other encoders besides one-hot encoder that can be used? Yes. If you like, you can create nominal encoding, means you can give integer values like 0, 1, 2, 3, or you can create your own key and then give those key values, okay? And for the target variable, they are using label encoding for the target variable. For example, your target variable is yes, no. Did you open the email right? Did the customer open the email? Yes, no. If like, you can use target label encoding to turn this yes, no into 1, 0, for example. PCA stands for Principal Component Analysis. It's a unsupervised transformation, which is mainly used for reducing the dimensionality of the dataset. So when we create dummy variables, remember when we create dummy variables, here we are introducing these additional columns. So one thing is, if you look at this first example, one thing is actually, if you know the first 3 columns, you can easily get the 4th column. You can calculate, right? So if these are the only 4 categories, if I know the values for the first 3 categories, for example, if this, for this row, if I know Bronx is 0, Brooklyn 0, Manhattan 1, I know that Queens is 0, because each row can only take one value of 1, right, for each categorical variable. So, I mean, this person here with salary 103 and vegan no lives in Manhattan, right? Not in Queens or any other. But that's why the Manhattan is 1. If Manhattan is 1, then the others are 0. For example, for this guy, index 1, if Bronx is 0, Brooklyn 0, Manhattan 0, then I know that Queens is 1. That means Queens is linearly dependent on the other 3, right? So originally, if you are working on econometric models, just for your information, if you are working on econometric models, if you put this into a model earlier, you would face with multiple linearity problem. Multiple linearity means one of the columns is a perfect linear function of the other 3. Okay, but now the new programs, actually packages, libraries are taking care of this themselves automatically. So just know that there is this this extra information that when you create dummy variables, one of them will be a function of the others. Okay, so what we do is normally we exclude one of them. That will be the base. So we exclude one of them because I know that that excluded one can be recovered from the ones that are kept in the dataset. But for scikit-learn, you don't need to worry about this. Scikit-learn, I mean, the code itself knows that these are the dummy variables. One of them is a function of the other 3, so you don't have a problem. But just know that this multiple linearity, if someone asks you, what was the problem here? What do you think about multiple linearity? Yeah, there is multiple linearity because one column is a function of the other 3. Perfect linear function of the other 3. So those discrete features actually are working perfectly for tree-based models, discrete features. So the tree models do not care about discrete features, but with scikit-learn, you still need to turn them into dummy variables. Scikit-learn still needs numerical values for your attributes. I think they are working on creating, making this addition to decision trees so that you don't have to turn your categorical or discrete features into dummy variables. But as far as I know, as of now, still, if you're using decision trees, you need to use dummy variables. Okay. After this slide, I'm gonna switch to. It's not, data frame is not same as database. Data frame has columns and rows, but comes with its own functions, methods. We call them methods because of this object-oriented. What is this? How are we concatenating? We answered this question. Okay. So what is the advantage of one-hot encoding to ordinal? Ordinal is you are creating an order. So we just gave the example, right? So 6 is greater than 5. Right? So if you're using ordinal encoding, sometimes it makes sense, ordinal encoding. For example, the example I gave you, freshman, sophomore, junior, and senior, right? So for some projects, senior, you can use 4 for senior, 3 for junior, 2 for sophomore, 1 for freshman, and it may work because I know that sophomore is coming after freshman, and then junior is coming after sophomore, right? So there is an order, and I can keep this order when I use ordinal values for this categorical variable. But if you do this for zip code, if you do this for example, borrow that we just saw, right? Then you will run into trouble, right? Because what makes one category value greater than the other, right? So if you compare 2 zip codes, you cannot compare their numerical values, right? Yeah. So if all the values were 0, borrow was missing, all the first 3 columns were 0, that means the last column is 1. Yeah. So when you have large number of values for a category like zip code, we call this high cardinality, then we are going to have this problem of data size exploding, right? So the solution for that is, what we do is, we are actually trying to find create a new feature that is going to give us some unique value, okay, for that categorical value. Like what? For example, for zip code, let me first introduce this data set. It's the house sales data set, okay, and this data set has this attributes. One of the attributes is zip code, right? This is a house data set, and this is the data set. Now this is zip code. So what we do is, instead of using the zip code itself, if you keep this zip code as it is now, this one, you need to create dummy variables. So instead of using zip code itself, what we're gonna do is, we are going to find in this case, and this differs from one project to another. In this project, we are going to find, because the target variable is house price, and we are going to find the average house price for each zip code. Right? If you have 1,000 zip codes, for each zip code, there are certain houses in that zip code. We are going to take the average of the house price in that zip code, and then use that average representing that zip code. Right? So this way, I mean, instead of creating, why we create dummy variables, why we are creating dummy variables? Because for this row, if this house is in this zip code, we want to make sure that this house is in a different location than this house, because they have different zip codes. And what is the impact of being in these different zip codes? So we are going to compare one with another, right? So that is why we are creating dummy variables. But in this case, creating dummy variables is not going to be very helpful for us. What we do is then, because each zip code is unique, instead of using zip code, we are going to create a new feature, and this new feature will be the average house price for that zip code. And most likely, this value will be unique for each zip code. Right? So that's what we are doing. For that, we are using target encoder. Again, just keep in mind, when you have a high cardinality categorical variable, instead of creating dummy variables, you might approach the problem by using your target value and then taking the average of your target value for each unique value of your categorical variable. So this target encoder is using zip codes. Actually, we are focusing on zip code. Now we are transforming zip code. When you fit on trained data set, we need your trained data set, both your label and feature set, because what you're gonna do is you're going to go to your feature, go to your zip code, and then you're gonna collect all the indices for this zip code. For example, 98029. You're gonna pick all the indices corresponding to 98029, and then you're gonna get the label values corresponding to these indices and take the average of them. Okay, so this is the transformed data set. As you see, for this zip code, I have this average price, house price. So you can do this manually if you like. And here we are doing this manually. What we do is we are taking our label, target variable. We are grouping our target variable by zip code. Again, our target variable and feature set, their indices are matching, right? Their indices are matching. So the first value of my Y train corresponds to the first row of my X train. Okay, so I group my Y train, my target variable by zip code. So now I created clusters of houses by zip code, and then I take the mean of those clusters. So this cluster, the mean house price. This cluster, the mean house price. Okay. Now I shrink my data set is now shrinking, right? So next thing is what I do is this is my entire set of averages for the zip codes. So this is my first 5 observations from my train data set. These guys, 1, 2, 3, 4, 5, X train head. I'm only taking the zip code of these 5, 98029, 98004. I already grouped my target variable by zip codes. So what is the mean value for this zip code, 98029? It's right here. 980. So this is coming from here. Okay, for this zip code. I tried to explain what the code is doing as much as I could. Now, if you like, let's do some practice. I think it's gonna be more helpful for you guys to focus, right? So let me see if you have any questions. Otherwise, I'm just going to start with the coding part. Will it be acceptable or better to use the 1 or 2 columns to represent the center of zip code area rather than the average pricing? As I said, you can be creative. You can find the proxies for zip code if you are sure that there is this variable that is representing zip code, and then that variable is taking some continuous values and unique. Then you can use it. When we have multi-cardinal columns, how we can plot? When you have a column with taking multiple values, like cardinality is greater than 1, what you can do is you can create box plots, right? Just to see how many unique values of each category you have in for that column. Target encoder is a transformer, yes. Okay, so let's get started with our exercise. So I know that you guys have this file. If not, I already shared the link and you should have access to this file. Okay, so this is our data frame. So let's just run this data frame. Okay, so now let's do some couple of things on this data frame, like the things that we already saw on the screen. So let's create the dummy. First of all, let's create the dummy variables. Again, pandas get dummies. Okay. Now the name of my data frame is df. You can name anything. And then just run this. It's that simple. So we created dummy variables for borrow. All right. So let's do a couple of things here. I just wanted to show you that if you like, you can check the D types of your df, your data frame, it has only 2 columns, right? What are the dtypes of these columns? Right? Salary is an integer, borrow is an object. It's categorical. Okay, fine. Well, what is next? Now, I'm going to create this. I'm just going to use this very simple data set, but do something a little bit complicated, okay, on this simple data set. So please bear with me. Let's go step by step together. This is the link, okay? All right, so first of all, let's import from scikit-learn. Let's import make column transformer. This is what I'm going to use, all right? And then I'm just going to import one-hot encoder as well. And it is pre-processing. Okay, or one-hot encoder. By the way, this is one H. This is encoder. Okay. Now, I already know that my data set has 2 columns. One of them is categorical, the other one is integer. So let's say categorical. I'm creating a new variable. I call it categorical. This variable will hold Boolean values. These Boolean values, true, false values will correspond to, in this case, if it is categorical, it's going to be true. If it is non-categorical, it's going to be false. Okay, categorical is df, which is my data frame, which is this guy. This is my original data frame. Okay, df. And I know how to check its data type, data types. Okay, if my data type is object. Okay, if my data type is object, then so let's see what's going to happen. Let me type the other one and then let's see what's going to happen. This is categorical. I'm just going to print categorical just to show you what happens with categorical. I'm also going to print this too. Not categorical, okay? Not categorical. This is taking not of categorical, okay? So the first one is corresponding to categorical. As you see, salary is not categorical. That's why the Boolean value is false. Borrow is categorical because its data type is object. It's true. And then when you take not of this, then salary is true, borrow is false. That means not categorical is numerical, right? Okay, so we know this, all right? And then what is next? So let's do something more. Now I'm going to also import. Now I imported one-hot encoder already here. Well, let me just add it here, standard scalar. And then let me run this one more time, okay? So I also included standard scalar. One-hot encoder and standard scalar are functions from, or classes from pre-processing. Okay, now I'm ready to create my column transform. Let me do this. I just give CT, column transformer. You can give any name, my CT. Okay, make column transformer. Remember, with column transformer, I'm going to take my data and I'm going to treat different columns differently. Okay, numerical ones, maybe I'm going to do standard scalar because that's why I imported standard scalar. The categorical ones, I'm going to do one-hot encoder. Okay, column transformer. Let me type this and then I'm going to check your question. I know there are a couple of questions. Okay, so let's do this. Just going to make it more readable, that's all, okay? So the first tuple is standard scalar, okay? So this standard scalar is going to be implemented on any column that is not categorical, so not categorical. By the way, if you like, you can also give the list of the columns, if you like. Okay, we'll do that too. We'll do that too. Okay, this is the first. Now the next one. The next one is one-hot encoder. One-hot encoder. Okay, and this guy is gonna be working on my categorical columns. Okay, so I just defined my make column transformer. Okay, this is a transformer. This is a transformer. So I can take this transformer, CT, I can fit it. When I fit, what I'm gonna do is I'm finding mean and standard deviation of my non-categorical ones, yeah, when I fit. And then I'm gonna transform. Okay, I'm gonna transform my data sets. All right, let's see what happens. See, nicely, I use standard scalar on salary, and I created dummy variables for my categorical variables. All right, so there are a lot of things you can do, and it can get at first complicated, but then it's very convenient. So let's go step by step, okay? All right, so can I make this a little bit more fancier? Not just for the sake of making it fancier, but maybe I can reuse it later. So just to make some habit of creating these make column transforms. Okay, so let's see. And let me check your questions. So please send the recorded session at the conclusion. I'll check with the Magnimind people to make sure that you will receive a link to the recordings. Can you please upload all updated? Most of them on drive are empty. Or okay. I think I uploaded the, let me check it, Aditya, I'm gonna check it. Tuple is, what are tuples? Tuples and lists are actually lists, but with tuple, you cannot update the content of the list. So when this is a tuple, sorry. So once you create a tuple, you cannot update the content of that tuple. Okay, I cannot change standard scale with something else when we have a tuple. When you have a list you are using brackets like this. This is a list. This is a list, and this is a tuple. Okay, the difference is list can be updated, tuple not. Okay, that is the difference. Yeah. Okay, so let's continue. Now, I'm gonna not only use make column transformer, I will use make column transformer with pipelines. So it's gonna be a little bit look messy, but it will be very handy. You will see that. So let me import this. I'm just going to take this down here. You can do the same thing. And not only make column transformer, but I'm also using column transformer. Sorry. This guy, these two are the same big line, not the same, but similar to like make pipeline and pipeline. Remember these two? With make pipeline, the names were automatically assigned by scikit-learn. With pipeline, you could name the steps. Same thing. Make column transformer, so we have steps here, right? This is one step, this is another step. you don't control naming the steps. With column transformer, you can name the steps, which we'll see in a moment. Okay. Let's also this time do some additional things like impute. Okay. Import simple imputer. Okay. And also let's pipeline. All right. So if you like, let's change our what happened? Okay. Let's do some, let's call this df2, okay? And let's do this. And let's change Brooklyn to Manhattan. And let's change this to question mark. I'm just creating some missing values, okay? So there's some missing value here, and this is a missing value too. NumPy is okay, let's use this one. That's fine. Oh, I didn't. How is that? Okay. Anyways, okay. Let's go this way. All right. So I created a missing value here. Let's continue. And I have a new data frame. So what I'm going to do is now I am going to create pipelines for numerical and categorical variables. Okay, so let's do it. First of all, I'm going to create a numeric transformer. Okay, I'm just going to call it numeric transformer. You can call it anything. And this numeric transformer is going to be a pipeline of the following steps. First of all, it's going to have an imputer. I'm just going to call it imputer. You can call anything. Okay, this is the name of this step. That's why I'm using capital pipeline so that I can name my steps. This is imputer, and this will be a simple imputer. I already remember imputer is filling in missing values. And let me use media. This is my first step. And second step is let's call this scalar. Okay. And this guy will be standard scalar. Okay. So, all right. This is a tuple. So I need to put my parentheses. Let me remove this. Okay, so this is my numeric transformer. I have two steps, imputer and scalar. So the missing values can come in different formats. You can put a question mark, it can be an empty space, it can be some not very meaningful value. Here we are being nice and then putting a question mark. So in reality, you're not going to have this nice missing value. So you have to recognize missing value is actually not meaningful entry. So it can be in any format, something that is typed not very meaningful. So here I just put a question mark here. Another thing is I checked it, so I remembered that NaN is a NumPy method. So I imported NumPy and then put this is not a number. Okay, here. So we have. I should have put it. Yeah. But anyway, so we have one column. This is missing values. It's actually very stupid. Let me change this. Let me put this guy here. Okay, now I think it's more meaningful. Yeah, so we have one, the salary is missing for this guy, and then borrow is missing for this guy, okay? We just artificially created some missing value. Again, missing value can come in very different formats, and that's one of the things that you might spend some time on to recognize what kind of missing values you will have. Okay, so this is our numeric transformer. We're gonna do the same thing for our categorical transformer. So categorical transformer, not exactly the same thing, but let's call this transformer. This is the name. It can be anything. And this is going to be a pipeline. Again, okay, and these are the steps. Okay, so the first step is, again, I'm going to have an imputer. But this time my imputer is going to be a different one, right? Because it's a simple imputer, but the strategy will be different, right? It's a simple imputer with a strategy of most frequent. By the way, let me change this to mean, because I don't have a, let's change it to mean. Most frequent, and yeah, this imputer is going to be working on this categorical variable, and I'm gonna pick the most frequent value or category and replace this question mark with that. So I need to put what I'm going to be replacing with. I'm replacing question marks with the most frequent value in that, for that column. Okay, so this, let's call this missing value. Is this, okay, this is the missing value. All right, so this is one transformer. The next transformer is gonna be one hot encoder, right? Let's call it one hot. This is our name, you can give any name. All right, and this is gonna be a one hot encoder, okay? And this guy will be working on borrow, all right? So we don't need to say this because we are going to say that this transformer will be working on categorical variables. That will come later. Okay, but one thing that we're gonna do now, one hot encoder, yes, it's gonna work, but remember what happened with pandas? We first created a dummy variable, a set of dummy variables for our training data set, but then suddenly when a new category came up in our test data set, Staten Island was not in our trained data set, and then we are going to have problem, right? So there is this data point coming with some unrecognized value, right? So what we're going to say is if you receive an unrecognized category value, so what we are going to tell to our transformer is, you know what, if you receive such a unrecognized value for a certain category, like unknown, category. So the way you're going to handle those unknowns is you're just going to, ignore it. So those data points that we don't have a corresponding value in our trained data set, right? We're just going to ignore them. That's what's happening here. Okay. All right. So these are categorical transformer. Okay. These are our two pipelines. The next thing is I'm just going to create my, again, you can give any name. This is the name of my column transformer. Okay, this is my column transformer with a small r. Very similar to, sorry. We are using steps for pipeline. I'm gonna be using transformers, okay, for this guy, okay. What are my transformers? Now I'm gonna be using my tuple. Again, I'm gonna give a name for my first transformer. Let's call it num. This is gonna be the numeric one. The numerical transformer is this guy, numeric transformer, which I just created above. Okay, and this numeric transformer, remember, we already let's copy this here, CF2, okay? So this numerical one will work on not categorical attributes, right? Okay, I'm gonna need another tuple. Let's call it categorical, cats. And this guy, this time using categorical transformer. Okay. And it's going to be using categorical attributes. So I need to rerun this. So that's can assign categorical. Okay. Okay. So preprocessor. I created my preprocessor as well. Now it is time for me to fit my preprocessor. Preprocessor that fit. What is it? My DFT. Okay, so let me fit, but also transform it. Okay, let's see what's going to happen. Says something is wrong. Am I missing any parentheses here? Doesn't look like. All this up. Can you guys see anything wrong? I need one more parenthesis here, I think. Somebody also found it. So somebody found it. I'm going to give the okay. Is there a transform that we can just drop entries on the list if certain values are missing? So it may, yeah, you can drop sometimes if you have a really some observation with lots of missing values, you can drop it. Does missing values and dumb values are the same? No. Missing value is you don't have the value. Okay, dumb value means you are creating a code for each value of the category. Like, let's say you have red, blue, and black color. These are 3 strings in your data set. So red, blue, and black color. So how can you represent them numerically so that you can run your data set into a machine learning algorithm? Then red will be 100, black will be 010, blue will be 001. So I just gave 3 different codes for 3 different colors. So these values that I gave these codes, I call them dumb variables. Another question? Yeah, it is needed. Yeah, correct, George. George, I missed one of the, I think I found it. So it should work now. Now the same thing is happening. Okay, so let's see what happened here. Remember, this is my numerical category, and I am using imputer with strategy mean and then a scalar. So let's, if you like, let me just cut this, okay, and then see what's going to happen. I'm just going to cut this, all right? Okay, let's see. So then I'm going to bring it back. So I'm using simple imputer here only. So what's happening is, this was my data set, my original data set. Where is it? This is my original data set, and I was missing this 5th value, right? The number 4. So now I replace it with 90.2. That is the mean of this column, mean of the non-missing values. Okay, so another thing is, let me put this back. Okay, another thing is, I am using one-hot encoder, so let me also take this out and then see what's going to happen. Okay, so as you see, I was missing this guy here, and I just replaced question mark with the most frequent one, which is Manhattan, right? See, Manhattan. I replaced that with Manhattan. I'm sorry, this one, Manhattan, right? And also then I create in the code for each of these borrow values, okay? And these are the codes. As you see, it's, again, a very simple data set, but I'm doing all these different things, right? So I'm using imputer with strategy mean and scalar on my numerical category, and I'm using imputer with most frequent strategy and also one-hot encoder on my categorical variable. All right. So that is actually big part of pre-processing, and you need to spend some more time for I'm talking about scikit-learn, to get into steps of this column transformer. That's going to come later, after you spend some time to digest what's happening here. But I mean, it's a nice way of combining pipelines with column transformers. Okay, so let's go through this exercise, if you like. You already have the data set. I shared the data set with you. So you can, again, follow me with this data set. Let me see if we have any questions. Just 1 second. Yeah, indent error. I fixed it. Thank you, Aditya. Regularly. Yeah, thank you, Rakesh. I fixed it. Thanks. Okay, so let's continue. Exercise 1, load the adult data set consisting of income data from the census, classifying adults in those earnings above 50K. We already looked at this data set before, right? So this is our data set here. All right. And I'm reading this data set. I already imported pandas. If you have not imported pandas, then import pandas as PD. Okay, so that you can use PD with CSV, and then let's also data.head. Okay. Let me do this. Let me copy. Okay, so that I know what's happening, exercise 1. Okay, so this is my data set. And let me just print the information about my data set. Remember this, right? We went through this info. So my data set has these attributes. And some of these attributes are, as you see, numeric. Some of them are categorical. I don't have any null values. And all of these guys have the same number of observations. Now, it looks like there isn't any missing value. It's very hard to detect missing value here, because you will see that in one category, missing value is coming in terms of question mark. And question mark itself is a character, and it is counted as a categorical variable. I mean, right now, it is counted as one of the categories for this data frame, which is not. So we have to detect it. So that's why it's a tiring business, really, pre-processing data set. You have to really get into your data set, have your hands dirty, and then be really, really familiar with your data set. Okay, so this is, let's separate this is our target variable. So if you like, you can simply say, this is my, okay, and then these are the features. Okay, my features are my data set after I drop income, right, which is the target variable. But when you drop the income, you need to know that I'm dropping a column, not a row. X equals 1 means I'm dropping a column. Okay, now if you like, we can simply check your features. It's gonna be the same thing. Right, I just dropped income. Okay, so this is the first exercise, right? Things will get complicated in a minute if you are waiting for complicated business. Okay, so let's copy the second piece. Okay. Experiment with visualizing the data. Can you find out which features influence the income the most? So this part, I think, requires some additional lecturing. Okay, I'll do my best, but I cannot finish this part as to the extent that I wish. So I need another lecture for that. Okay, so but let's begin. First of all, let's separate continuous and categorical ones. We already know how to do that, right? So, I mean, there are different ways of doing that, but here I'm gonna do it this way. So this is my data features. This is the data which only has the features. Again, there are different ways of doing this. I'm trying to show you different ways. So this is now the column, names of my columns like age, work class, education, all the column names of my data features dataset. Okay, but I only want the column names that are numeric. Okay, I don't want work class, I don't want education, but right now, all these columns are here right now. So I'm just going to drop the column names that I don't want. Okay, I only want to keep the columns that data features D type, okay, is, I'm going to use this one, you see integer. I'm gonna be specific now, okay, integer 64. Okay. So what is continuous now? Continuous is holding the names of the columns that are continuous, that are numeric, right? Like age, education, number of education years, capital gain, capital loss, hours per week, right? Okay, so I can do the same thing for categorical. I'm just going to be lazy and copy and paste. Let me call this categorical. Again, data features, column data features. This time, this is gonna be, actually, I don't need to change this. Not, yeah, that's what I did. Not equal to X, anything, because if you look at your data, you have only two categories, integer 64 or object. If it's not integer, then it is a categorical, okay? Okay. Right. Now, categorical is holding the column names that are categorical. Okay. Now, I just want to show you what this means. Okay, what this means. So let's be more specific about this. So data features, I want to check this guy. This is 0, this is 1, this is 2. This guy, I want to check what happens if I implement this on this guy, okay, this third column. So data features, and I am going to PIAIC is going to allow me to slice my data frame. So this is my entire data frame. I'm just going to slice this part, which is, this means this column means everything, all the observations, all the rows, but only on this column. What is the index of this column? 0, 1, 2. 2. Now I'm gonna check that column's D type, if it is integer or not, okay? It is not. All right, so this guy here is actually, true, false, false, true. It's a set of Boolean values. All right, now, this is an array. Continuous and categorical are right now are array. If you like, you can turn them into a list, okay? Like continuous. I just type it. Okay. Now it's a list. So this is an array. It's an object. Now this is a list. We're gonna use this list later. Okay. Okay. Now we are going to do some plotting. Okay, some plotting. Any questions? I'm not recording. Sorry, guys. Yeah, sorry about that. Excuse me, can we first plot the correlation between features and income and guess somehow first? You can, to check which one is more influential on the target variable, you can check the correlation. That's what we do for numerical attributes, actually. When it will be better if you use salary to infer what is like the value of borrow instead of using the most frequent and salary to infer what is like the value for. You could do it, but for this data set, it's gonna be too much. Yeah, but you can do it. Actually, this is model-based imputation. Yeah, you can do it. You can use one column to infer the other, and then the one column to infer the other. But here, data set is just 2 columns. Yeah, sorry about that, guys. You missed some part of the class. I forgot to record it. I think I'm too sleepy. Okay, so let's do some plotting. Import. This time, instead of using PyPlot, I'm gonna be using Seaborn. It's another library, very handy and popular. Okay, so we're gonna use this one. And then remember this, we did this before. We are creating figure and axis. Our figure is gonna be a number of subplots. What is the number of subplots? I'm gonna create 5 subplots, 3 by 5. And this is the size of the entire figure. All right. So these are my, I'm adding one line here, but let me show what happens with that lines later. So let me add it later. Let me go through a couple of lines and then I'm gonna check your questions. Okay, so let's get started. What I'm gonna do is I am going to, I mean, this doesn't mean much, but I'm just gonna show you that you can do this. What I'm gonna do is I'm going to create the, remember our target variable is less than 50K, greater than 50K. Our target variable is categorical, right? Less than 50K, greater than 50K, income. Income takes only 2 values, less than 50K, greater than 50K. And we have numerical values like age, education, number of years, capital. So I'm gonna create box plot of my numerical columns. I'm gonna create 2 box plots for each numerical column. One box plot will correspond to income less than 50K. Another will correspond to greater than 50K. Okay, what I'm gonna do is actually, I'm gonna divide age into 2 groups. Everyone who are the age of all the people with income less than 50K, age of all the people with income greater than 50K. Then I'm gonna see how their box plots are different. Okay, that's what I'm gonna do first. Okay, I X in. Okay, so now axis is 3 by 5. I'm raveling it so that I'm gonna have 15, an array of 15. Okay, because I went through this earlier, I'm being brief on this. I remember going through this with you guys. Okay, and then because I have 12 attributes, so when I is greater than 12, okay, I mean 13 attributes, when I is greater than 12, I'm just going to turn off, should be, I'm just going to turn off that that figure. Just going to set it visibility C visible. Okay, it's gonna be, then continue. Okay. Now, I'm first going to work on the numerical ones, then I'll add the non-numerical ones. So if data features, remember data features is a set of the features. If my data features, I am going to look at my data features. I'm going to check each column. Okay, ilog.ilog is going to check each column. I'm going to take a slice from my data set. This is the ith slice. When I is 0, I'm looking at the first column. When I is 1, I'm looking at the second column. So if the ith column of my data set, okay, if its D type is integer, that means it's a numerical one. Right? Now I'm looking at the numerical ones now. Okay, if it's numerical, okay, I'm just going to simply create a box plot. That's all. Okay, my box plot will be y and x axis. Y axis will be my data features, my data. This ith column. So I took a slice. If it is a numerical one, now because it is numerical, I'm going to create a box plot of the numerical column. Okay, and then y values, the perpendicular axis will be the column values, and x axis will be the income. Okay, x will be income. Remember, I already created income here. Here, right? Income is my target variable. Okay. Anything else? And of course, AX is AX. So this box plot will be drawn inside this AX here. Okay. All right. So let's run this. Of course. Okay. I don't want to just type the name of the plot. Okay. Now what? Now what? Okay, so we are having some problem. The problem is neither the X or Y says numerical. Can you see what is wrong here? This should be I, right? See, small mistakes, I'm serious, I'm sleeping now. Small mistakes are causing problems, right? So you cannot see at first what's happening. Okay, so we skipped the ones that were not numerical. We only focused on the numerical features, and we are creating box plots for each value of income. Income is, remember, our income was categorical, right? Less than 50K, greater than 50K. We just want to see, right? So how For example, this one is age, right? How age is changing when it is less than 50K, greater than 50K. When for those who with income greater than 50K, the median age is greater, right, than for those with less than 50K. Age has an impact on income because, as you see, the distribution is changing, right? I mean, what is this? Hours per week. Again, the hours per week has an impact. To me, it's not as effective as age, but still there is an impact. If these two guys were almost the same, right, at the same level, then that means this continuous variable has no impact on income, right? Okay, so these guys, somehow we have so many outliers. So that's why, I mean, we see that, I mean, we need to focus, actually, most of the data points are here, so they're very small. We have a lot of zeros, actually. That's what happens here. We have lots of zeros. That's why we see them. Probably they are missing values. I don't know. So I really don't know. So the capital gain and capital loss, we have lots of zeros. That's why we have this shape here. Okay, let me see if we have any questions. Yeah, Sibon, somebody, Rodrigo, give the answers. Thank you. Yeah, thanks. You were trying to help me. Thank you to fix the problem. Yeah, thank you, Andre. Okay, let's continue. Now let's focus on the non-numerical ones. Okay, if it is integer, we do this. If it is not, right, else, right? Now we need to think what we can do. Again, we can do different things. I'm just going to show you one thing. So you can do different things maybe. So what I'm going to do is I'm going to count how many different values. Now, if it is not integer, then it's a categorical variable. If it's a categorical variable, it has different categories, right? Now I'm going to count how many unique values for each categorical column, right? For example, if the categorical column is talking about the level of a student at the college, like senior, junior, sophomore, or freshman, we have only 4, that cardinality, right? We have only 4 different unique values. That's what I'm going to count. So if it's not numeric, then it is categorical. Then let's do this, right? I'm just going to count this one thing that I'm doing, feature count. So this guy, feature count, is counting how many for each category variable. For example, how many sophomore, how many junior, how many senior. Okay, that's what I'm counting. Then, so let me show you what this does. Remember, when I was 2, it was a categorical variable. Okay, so you're simply counting. This is education level. How many masters? How many people with 11th grade? How many people with 10th grade? So, okay. So then, if you look at the index of this, okay. So, index is simply giving the names of these different category variables, right? Like high school graduates, some college, bachelor's, master's. So because I have so many different categories here, if I want to plot it, like box plot here, it's gonna be too much. You can try it. So that's why I'm gonna just take the first 5. So that's what I'm gonna do, okay? Okay, I count the features. And then if, okay, length of these different features again, there are many different ways of doing this. I'm just doing this. So this is also a programming exercise for you. So if this is greater than 5, in other words, if I have more than 5 different categories, if the cardinality is more than 5, right? So I'm just going to take the first 5. That's all I'm going to do. So plot, this time a bar plot, okay, SNS bar plot of my feature count index, but only up to 5. Okay, only up to 5. And then feature count, number of counts, values. Index is names of the categories, values is the corresponding values. Again, up to 5. This is index, this is values. Index values. I'm just going to take the first 5. Okay. All right. Anything else? Yeah. If it is greater than, then if it is not, else. Okay. If it is greater than 5, then do this. Else, it's just going to do the same thing. But not just 5, the whole thing, right? Okay. Let me add this here. This is just the intensity of the color, alpha equals 0.9, and then this is going to be AX. Okay. Okay. So this is how it looks like, but as you see, there are some the titles are just mixing. Maybe we need to leave some space in between. So that's why I'm just going to do this figure tight layout. There is no way you can remember all this, okay? Just know that it exists so that you can use it when you need it. This is not fixed, this is fig. Yeah, I just put some space, and then now if you see, as you see, I also need to rotate the so that I can rotate so that I can see those labels, right? So that's what I'm going to do next. Each AX, I'm working on each AX. Yeah, I'm going to set the title. Okay. So this is a placeholder. It's holding, this is another placeholder. Now, these placeholders are holding place for this following guys. I is the index of the figure, like 1, 2, 3, and then data features dot columns. This is the name of the columns of data features data frame, but which column name? Ith column name, right? Okay, so this is the title of each figure, and then I'm going to also set the X label. I'm just going to set it empty, okay? And then I also want to set the Y label empty. Again, there are different ways of doing this. You can find it very primitive, but it's okay. it works. X. Now I'm working on these guys. Tick labels. I'm just rotating them by 30 degrees. I hope it's gonna work. Okay, so I mean, just an exercise for you so that you can work with figures, create some figures. Again, well, if it is continuous, if my feature is continuous, I'm creating these box plots. If it is categorical, I'm simply creating bar graphs. Okay. Now, of course, what is this? I mean, it's not enough. Yeah, I know. Actually, to determine which of these features actually are most important, you need to look at the chi-squared scores and ANOVA scores. Okay, so those were the two things. Actually, I have the code ready. Maybe I can share it with you. But to understand what is going on, we need another lecture for that, actually. That's one thing. Another thing, you see, we have question mark here. Clearly, this is not a, this is a missing value, right? So work class, we don't know. But because it was entered as a text, right, as a string, it was counted as a different category value, which is not. So we need to take care of this work class. All right. Question. We don't have class next week. What's going to happen is we might have class. Just wait for announcement. I'm thinking to start with regression. So I think enough with pre-processing. Not enough, actually. We need to do a little bit more than this, but I'm thinking to start with regression. Yeah. And then maybe another session might come. Okay, I will upload the latest Jupyter. Yeah, we're going to have another lecture, hopefully. Okay, guys, I am going to stop here, all right? So I'm really tired. I'm going to stop here. I'm going to upload this file, and I'm going to also add a couple of things more, so you can yourself practice and then see how it works. And hopefully wait for the announcement for Magnimind. If you receive an email or announcement for a lecture on regression, we can also study on regression. I'm thinking to give regression, then decision trees, supervector machines, neural networks, if time permits, step by step. I want to go. Okay, thank you so much for listening, and I enjoyed spending time with you guys. I hope you also enjoyed and then had some benefit from listening to me. Thank you. Take care. Okay, bye.